Hey, so we're starting a new unit. It's all about trig word problems um, with lots of different things inside of these trig word problems. So Charleston, South Carolina has some tide height that I looked up. Uh, 5:11 a.m. The tide was the depth at the end of the pier was 4.9 feet. A few hours later, about 6 hours later, we have low tide, zero point 0.7 feet. 5:19 p.m., back up to high tide, and 11:33 p.m., a little before midnight, we're back at low tide, zero point 0.6. So here's what we've got. We've got some sort of situation like that. And you know what? I think we're going to be thinking about trying to come up with a trig equation for this. These are trig scatter plot problems we're going to do for the next few days. And essentially what we're going to do is we're going to try and take the data, use the data to build a trig model. In this situation, I want depth as a function of time, some sort of d of t thing. And there will be some sort of tricky thing over here. Okay. Once we've built that model, we're going to answer some questions. To use the model. And we're going to do that in two ways. One, you're going to be given an input and asked to find an output. Or you're going to be given an output and asked to find an input. And a word about these two types. I do them very particular manner once I've built the model. If I'm given an input, I usually use the table feature on my calculator. If I'm given an output, then I graph the output in Y2 and do second calc intersect. Yeah, second calc intersect. Okay, so use the table when you're given an input, graph, and second calc intersect to when they give you an output. All right, but first, before we get to any of that application stuff, we've got to actually build the model. Okay, and there are some challenges here. I think, especially at the beginning, especially when we're doing our first problem, this is sort of like, whoa, how do I build this weird model thing he's talking about? Sure. So first, I can't type these in my calculator. And because I can't type these in my calculator, I can't ask my calculator to make a scatter plot for me. So the first thing I want to do is I want to convert these hours and minutes to be a decimal number of hours. So here's what I mean. Let's say that t equals 0 is midnight, for which this is 5 a.m. Okay, so, and I know that this first moment in time is 5 hours. I've got 5 hours there, but what portion is 11 minutes of 1 hour? Okay, well, 11 minutes, and we want to convert to hours. We want to get rid of minutes. Well, except there's 60 minutes in that hour. Good, so we're going to cancel those, and we're going to have 11 over 60. Well, when I take 11 and divide 11 by 60, I get 1.833233. So I'm going to call this 5:11 a.m. 5.1833333. Okay, now what about 11:26? Well, This is still 11 hours after midnight, so I'm going to start with 11. But I need to convert these 26 minutes into hours. And again, I'm going to take 26 minutes and multiply by 1 hour over 60 minutes. So I'm really just taking 26 and dividing by 60. 26 divided by 60. And I get 0.433333. Okay. 5:19 p.m. Now, careful, this is not 5. Noon would have been 12 hours after this, and this is 5 hours after noon. So 12 plus 5, I've got 17. Now, 19 divided by 60 minutes in an hour, and I get 0.316666. Now this. Well, I know if I get back to midnight, that's 24 hours have gone by. So if I'm not getting back to midnight, this must be 23.33 divided by 60, and I get 0.55. Now, this I can put in my calculator. Okay, I'm going to put these times in my calculator. Please notice here, we didn't have 11 twice or 5 twice, right? We had to sort of move, some students say, to the military clock for this, except no, it's not even like the military clock, because if I had some more data that brought me into the next day, these numbers would just get bigger and bigger. They wouldn't cycle back through to 0. Okay, so now that we have this, what do we do with it? Well, I want to plot the scatter plot. Now, I want to make this show up on my calculator. I have included for you a list of notes on putting a scatter plot into your calculator. Here it is. This is Trig scatter plots and word problems, sinusoidal, graphing sinusoidal scatter plots. So right now, I want to load my data into the stat edit L1 for the independent variable and into L2 for your dependent variable. So that means come over here and press that stat button. See that stat button? That's the button we want to press. And we want to edit. So we hit edit. Now, into list 1, if you have some stuff already in your lists, up arrow, clear, nothing happened. Hit enter. Up arrow, clear, nothing happened. Hit enter. All right, so in L1, I said I was plugging in the times, 5.184 and 11.4333 and 17.31666 and 23.55. Okay, so I've got our 4 times in there, and now let's place the depths. 4.9, 0.7, 4.4, and 0.6. Okay, well that's good. Next, what does it say? Next, go to Window and set the window to the high and low y values. Oh, the high and low values for both independent and dependent variable. Okay, so my low is, that 5. I could go back, I guess, to 0. And my high is 23, so 24. So my x's are going to go from 0 to 24. My y values, well, 0.6, 0.7. I guess I'll start at 0 and go up to 4.9, up to 5. So window, we're going from 0 to 24. Steps of 6. And y min, 0 to 5. Right. Yeah, I don't see it. So where is it, Mr. Koopa? Well, so here's the thing. Notice it says here, finally, using second y equals, turn stat plot on. Okay, so second y equals. See how plot is off right now? I want to turn it on. So now, when I hit graph, I see those 4 points plotted. You know, I could also, let's say, instead of building the viewing window ourselves, let's say, you know, I wasn't paying attention, I did zoom standard, and I see one of my scatter plot points. And I can go, oh no. You know, if you go to zoom and then scroll down, zoom stat. Zoom stat will automatically form the viewing window that fits the data you typed into list 1 and list 2. Always. So whatever you type in these, if you do zoom stat, you'll automatically get the viewing window to contain your data. And so I like zoom stat a lot. Okay, so we've got these points plotted. Hey, and remember, if you forget anything, it's all right here in this paper, which means it should be in your team right now. Okay, so our goal is to try and build a graph that connects those dots. Yeah? Next, we need to find the line of best fit. You can use sine or cosine for this, but I generally use cosine because in order to find the starting and ending points, you only need to have 2 maxes or 2 mins to work with. And here we have 2 maxes and we have 2 mins. This is perfect for cosine. Some people use sine. Yeah, sine is really hard. I mean, here's what we've got. We've got high tide, a low tide, we have a slightly lower high tide, and a slightly lower low tide. Okay? And we're envisioning some sort of trig function. And it'd be cool if we could hit all the points perfectly. But you know, in the real world, we often can't. And that's why we're calling this line of best fit. You know, we might have something like that, you know, where we're getting close to a point. I mean, so many different things. But what I want to talk about right now is actually this notion about sine versus cosine. Okay. So I'm starting here and going down to that one, up to that one, and down to that one. And I'm thinking about here, oops. Yeah, no, that could be the sinusoidal axis. That's good. Y equals D. Okay. Well, when I'm looking here, my graph starts not on the sinusoidal axis. It starts high. And so I'm thinking about using positive cosine. Now, if you wanted to start here, well, there's 2 problems with that. First, I don't know where I don't know what time creates this point. I know it's the time when we hit this sinusoidal axis, but I don't even know what the sinusoidal axis is yet. So, yeah, sine, not so keen. But if for some reason I happen to know what time this was, then I could start here with a negative sine graph and make this time be my C value. I would much rather start at the beginning with this. Okay? Okay, but that's just me. I mean, you could do sine from over here, but again, I need to know the D value, and I need to know the time when I have that D value, and I don't have any of that information yet. I could start here with a negative cosine graph, and I would make my C value be this time. Okay, 17.316666. Okay, so I have some ideas. I'm thinking positive cosine, but 1, look at scatter plot and decide which function, cosine or sine. Okay, so I'm going with cosine on that one. Okay, next, when we go to make these make model using y equals a sine b two parentheses because we're going backwards, or y equals a cosine b x minus c plus d. Doesn't matter which of these you use because, well, I guess it does matter because you've already narrowed it down to this one or this one, and that's the one you're going to go ahead with, okay? And really, the choice is just based on what do you see. Do you see something starting high and ending high? Do you see something starting low and ending low? That would be negative cosine. Do you see something starting on a midline going higher and lower and then back to the midline for positive sine? Or are we starting on a midline going low, going high, and then back to that midline? Negative sine. What I see tells me which of these I'm going to choose. Okay, so I'm going to choose to use the cosine one. And I have to find these four values. That's what I mean by making the model. I have to find each of those values. Okay? So let's see what you remember. This was amplitude. This was my vertical shift. That's right or left shifting. And that's horizontal compressing and stretching. Okay? And I would like to do this always in the same order. I'm going to, 1, find D. And the way I find D is I average the high and low y values. Okay, so now here's the thing. This low y value and this low y value are not the same low y value. So, should I take this one? Should I take an average of those? Yeah, I don't have a good answer for you. Okay. And the high y values? Well, these are my high y values, but they're not the same. And so, do I take the highest of the high y values? Do I take the average of the high y values? And I think what we should do is we should look at a couple of those cases and see what we're thinking about here. This is really not just write the equation of the line of best fit, but we're really trying to think about how to actually model this data. And people get paid lots of money for being able to do predictive modeling like this. I mean, lots of money. I mean, like so much disgusting money. You could just take a bath in all that money and then change that tub for your next bath the next day. So with that avarice in mind, let's say that we'll start by taking the highest high and the lowest low. And so we want to average these values. So 4.9 plus 0.6 over 2. I'm adding two numbers together, so I'm dividing by 2. And this is 5.5 divided by 2. And that's 2.75. 5.5 divided by 2. And yeah, 2.75. Okay, so I'm going to go with 2.75 here. Nice. Now my A value, 2. A is going to be high y value minus D, or D minus low y value. Okay, so and if high y and low y, so look, if I started with these as my high and low y, I'm going to keep using these. So I'm going to have 4.9 minus 2.75, or I could do 2.75 minus 0.6. Either of those will generate an A value for me. So minus 0.6, and I get 2.15. And if I use this one, yep, same thing, 2.15. So now I have my A value. Okay. Well, we've got D, we've got A, but I still need to find B and C. So let's take a look at C. C is the easy one. See this graph? And look, this is the only time I use trace. That, because we saw this as a positive cosine graph, and I know cosine starts high, I want that x value, that x value, 5.18333, that x value is my C value, right? It's the input value for where our trig graph starts. Our trig graph starts here because we saw a high cosine. Okay, so my C value is going to be that. Good, and so the only thing left is B. Now, remember that we said back in our trig graphing unit, we said that B, well, actually, we said that period was 2 pi over B, but now I'm going to multiply both sides by B and divide both sides by P to get B equals 2 pi over the period. So if I could figure out the period for this function, then I could put it here and see 2 pi divided by that number to find my B value. So let's think about this. Period is the distance from high point to high point, or low point to low point. So I know that if I'm going high point to high point, I could look at 17.316666. Right. No, I don't know that one. 17.316 minus 5.18. 1, 2, 3, 4. So by using the x value or the time for the two different high tides, I have these high y values, and so the period is the distance between them, or the amount of time between them, and that seems to be about 12.133 hours. Well, with that in mind, let's try using the two low values, 23.55 minus 11.423. I get a number that's similar, but is definitely not the same. And no, I can't tell you which is the better one to use. I just pick one. Here's what I want to say to start. Okay, so we've got B value as 12.133, because that's the one I found first. Okay, so we've got a D value, A value, the B value, and the C value. Okay, I'm going to erase some other stuff so I can reclaim some workspace. So A equals 2.15, B equals 12.133, C equals 5.18333, and D is 2.75. Okay, now let's put this all together in a model. Remember, when we go backwards, we use the double parentheses. So I have 2.15 cosine B value 12.133, another parenthesis, x minus 5.18124, close 1, close 2, plus 2.75. Okay. Oh, by the way, must be in radians. Don't forget, since we're about to do a trig graph, we want our graphing calculator to be in radians. All of these values are based on us being in radians. So now I'm going to go to mode and check. Yes, I am. That's great. And now to y equals. And in y equals, I'm going to type. I've already typed it. How convenient. Yes. Yes. Plus 2 plus fabulous. Now, we've already been set up to do zoom stat. We already have that viewing window that shows us our scatter plot points. So now when I hit graph, I get the scatter plot points. And what the hell is that? Well, that's pretty and all, but no. Something gone wrong there, buddy. I've got my X. Oh. That's beautiful. Which set of data am I looking at? Right? No, my data's the right data. And here, and I am in radians, good, and y equals. Well, you know, sometimes rather than try and find it, I'll just type it in again. Cosine. Our b value was 12. Oh, I know what happened. You remember how I said that b was 2 pi over the period? And then we said that the period was these times the distance from here to here. Yeah, guess what? That's the 12.133. I need 2 pi divided by that number. Oops-a-daisy. Okay, so we're typing in this formula, and I need, let's see, it's 2 pi divided by 12.133. Okay, and that's my b value, and x minus 5.18.225, no, close parentheses, plus 2.75. And I'm opening 2 pi divided by 12, and then we'll set parentheses here. Little parentheses closing. And shouldn't there be 2 parentheses here for closing? Second insert parentheses. Oh. Well, I think this looks really pretty good. I mean, I'm a little frustrated by that. And so, maybe we should say, well, what if we changed our A value? Or I guess that means we have to change our D. Because what if instead of this point and this point, what if we used the point in between these 2 points, these 2 values, for the purpose of finding D and then A? So I've got 4.4 plus 4.9 divided by 2, 4.65. So maybe when I go to calculate my A value, remember we said A was high Y value, 4.9, minus D, 4.65, or 4.65, that D value, minus 0.6, our little Y value. So 4.9 minus 4.65, and I get 0.25. I missed something? That can't be that. That can't be that. Oh, that's the one I'm using. I'm using I didn't want to subtract those. I'm taking the average. The average is 4.65. Good. And my low is still 0.6. So 4.65 plus 0.6. And if I divide that by 2, I end up with 2.625. 2.625. Well, originally I was using these values. Okay, so this is my new D, and my A is going to be high Y minus D. So that's 4.9 minus 2.625. 4.9 minus 2.625. And that gives me, for A, 2.275. And here we're using 4.65. No, we're not. We're using 2.625. Okay. So let's go over here to y sub 2. And let's type in our new function. 2.275 cosine 2 pi divided by 12.132 x minus 5.18 2.33 close to parentheses plus 2.625. Now I'm actually going to leave this one off for a moment. Just graph the second one. Yeah, see, so this is our tweaked one, and our tweaked one, at least on first tweakage, doesn't look better than this other one. And graph. Oh, yeah, this looks so much better. So I guess what I would say is, if our revision, if our tweaked version was a little closer here, but a little further away here, maybe it wouldn't matter to me which I took. But maybe if, like in that tweaked version, I mean, we seem to be off in a bunch of places. So sometimes graphing them together can help too. Help you decide which one you like better. Yeah, that extra A value is really just stretching this thing. So I think we're just going to go with the first one. Don't worry, you'll have plenty of opportunity to practice building these models and to spend some time thinking about tweaking. And I guess what I would say is, when I'm thinking about trying to get my graph to hit those points, I want to think in terms of transformations, because changing the line that I come up with is going to be based on changing these values. And all of these values represent different types of transformations. My A value is a vertical stretch or vertical compression. My D value is shoving the whole graph up or pulling the whole graph down. C value is shoving the graph to the right or shoving the graph to the left. And my B value is playing the accordion. It's stretching horizontally, it's compressing horizontally. And so I want to think about, when I look at this scatter plot and the line that I've come up with, I want to think about which changes I need to make. Do I need to go like this? 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 Do I push everything up? Do I put everything down? Do I move everything over or everything over? When I come to a decision about any of those, that informs me as to which of these I need to change, okay? And so we tried an example of tweaking. We said, well, I'd like to be closer to that point. And so we could do that two ways. We could drop the graph down, but as I get closer and closer to that point, I'm going to get further and further away from that one, and that one, because the whole graph is coming down. So I thought, instead of bringing the graph down, I thought about changing the A value. And I thought, well, hey, what if we took the average of these Y values? Yeah, so we took the average of the high Y values, and that gave us that 4.65. And we said, okay, our D lives halfway between that 4.65 and that 0.6. And of course, if we want the average of that high Y value and that low Y value, we need to add those numbers together and divide by 2. So I end up with 5.25. Let's just recalculate just to make sure. 4.65 plus 0.6 divided by 2. Yeah, there we go. So once I've established where that midline is, then I want to figure out an amount above and amount below. And so we did high Y minus D and came up with 4.65 minus 4.65 minus 2.625. Okay. Hey, that's not this. Uh-oh. I think I'm going to check again. Okay. I'm taking the average of these high y values. There's the average. Okay? Next, to find d, I'm going to take my low y value and my high y value. And I'm going to add those together, 6, and divide by 2. So 2.625 is our d value. Good. Now, a is always going to be high y minus d, or d minus low y. Well, we kind of futzed with the high y, didn't we? And our high y, we didn't use 4.9. We ended up using 4.65. So 4.65 minus 4.65 minus our d value, 2.625. Yeah, I got 2.025, not bad. Huh, interesting. Well, let's try that. 2.025 for our a value. 2.0, second, insert 25. Okay. Oh, that's very interesting. So let's compare it with the other one. By the way, if you take your arrow all the way to the left and hit enter, you can scroll through a bunch of different selections for how this will graph. I'm looking for the one that's got diagram. Thick line. There we go. Okay. And what? Sorry. It's the old d value, not the new d value. 2.625. Okay, what do we think about this? Well, that's interesting. Which do you like better? Do you like that one? That's our tweaked version. Or do you like our original? What's our original? 4.9 plus 0.6. 4.9 plus 0.6 over 2. 5.5 over 2. So we had 2.75 for our d value. And our a would be 4.9 minus that, which is 2.15. Cosine b value. The b value didn't change. It was 2 pi divided by 12.3 x minus 5.184 close to parentheses plus 2.75. Okay, so I've got these two functions, the original model we computed and our tweaked version. Which do you like better? Those of you with color calculator screens, this is so much easier. All right. Well, which one do you like better? The dotted one comes close to that. The bottom would okay for either of them. The top gets close for that. It looks to me like the dotted one is better. Let's turn off the solid one. Oh, that's bad. So that's our original. And this is this. I know, and the scatter plot points are gone too, because I turned those off. Wasn't that clever of me? Yeah. So plot 1, up arrow, hit enter, because when that's not shaded in like that, I'm not going to be graphing it. Ooh, heads up. After we're done with these scatter plot problems, sometimes people go to do something on the graph on the calculator with an error message. That error message is because they haven't turned the plot off. And so, yeah, you might have to turn plot off. You might have to turn plot on. I need to have plot on for what I'm doing. Okay, so we had these two, and I was wondering which I liked better. Here was our original one. It's a little low there. Oh no, this is our tweaked one. It's the dot one. And our original one is this one. That's a tough call. And for this reason, I actually, because it is a tough call, and we don't know, yeah, it is a tough call, and it is a judgment call. But if we build the wrong model, or if we even build different models, then when we go to use that model, your answers are going to be different from my answers in a significant and meaningful way. I mean, I would have leeway when you use your model to make a determination to predict something. And I would have, this is the number I got, and maybe I would take 2 more or 2 less as well. Give you a sort of wiggle room so that yours doesn't have to be exactly like mine. Okay, so, yeah, I think I liked, I don't know. Yeah, I really wish I had that color screen. I think that dotted one is just like it's a little further away over here, but it's closer here. I feel like I'm splitting that difference, and that seems to be, in my mind, a little bit more like the intent of the graph. Okay, so we've got 2.025. And this one is 6. Oh, let me try it again then. Wow, I like a lot of what's going on there, but I'm having difficulty seeing it. So I'm going to turn off the second one, which was our original one. Yeah, I got much closer to that point. I got a little further away from this one, but I got a lot closer to that. And I think I'm going to go with that one. I think I'm going to take our tweaked version. Cool. So, but let me also write down. Oh, I'm just going to keep it there. Yeah. So we've got these two models, and what I'd like to do now, once we've built this model, let's use it to predict something. Okay. So we've got here. We've got here. Sorry, I've just been distracted by my notes. I've got a lot of examples here. That's very interesting. I kind of want to put this in and compare it with ours, because this says best. Okay, so let's see what we got here. I'm going to put this one down. 2.3 cosine pi divided by 6 x minus 1.5 this. I can't believe this is going to fit through that. Whoa! Well, I don't like that one best anymore. That no. So, and then this one was the original one. Well, I think I like the original one better than this one, but I do think I like our tweaked one better than either of the others. So I'm going to turn those off. And I'm going to turn those off. Okay, so what shall we predict? Well, there's two things, right? We said we would run into two types of questions. One question where we are given an input and asked to find an output, and another where we're given an output, but we're asked to find an input. So, which one is this? A. What will the tide be on 317 at midnight? Okay, so this, by the way, is 314. Okay, so 314. Well, I know t equals 0 is midnight on 314. And I want midnight on the 17th. 14th to 15th, 15th to 16th, 16th to 17th. So I'm going to get to midnight on the 17th by going 3 days, or going for 72 hours. So they've given me a time here. They want me to plug a time into this function. And you know, you could take that time number and plug it in here and subtract that number and multiply by it. Yeah, why don't you just go to the table? Second graph gives you table, and then type in 72 hours. Okay, so 0.60139 is the predicted time. In fact, we could turn on all of the marks. And when we go over to the table, we could in fact compare them. And so I see that I've got 0.578, 0.602, and 0.601. They're all pretty close. And so I feel, even though they're not the same, I feel like I could say with some degree of confidence that the tide is going to be between 0.58 feet and 0.6 feet. Yeah, 2/10 of a foot, 2/10 of a foot. A foot is 12 inches, 10 divided by 10. So, yeah, not off by a lot. So, okay, what will the depth be? So we said between 5.8 and 6. Okay, approximately 5.9. Oops, it was 0.58 and 0.6, so 0.59 feet. Approximately 0.59 feet. Okay, so I use the table when they've given me an input. They gave me 317, and they said 72 hours. What if they had said not midnight on 317, but 1 p.m. on 317? Well, here's how I can do it. We know we're starting on midnight the 14th, and we know from the last problem that it's 72 hours to get to midnight on the 17th. But I want 1 p.m. on the 17th. How many hours after this midnight on the 17th would 1 p.m. be? Well, going from midnight to noon will be 12 more hours. And then going from noon to 1 will be 1 more hour. So I'm going to have 70, 85. So if they ask about that, I'm plugging in t equals 85. And I go to my table and I put in 85, and there I go. I've got 0.84, 0.855, and well, that's very different. Yeah, that last one that I put in, I don't like that one at all. The first two, yeah, I like those. Okay, so, and we get depth equals, what did we say? 1.8. 4.85. How about 0.845 feet? Okay, so you should be able to evaluate something like that. Now, what happens if instead of giving us an input, they give us an output? When will the tide next be 3 feet? Well, this is a depth, and so this is our output. And I want to know when our model has that y value. So we said in this situation, we would take the models and we would also, I'm getting rid of this one I thought was best, but I don't think it's best anymore. And we plug in our output. And so I'm wondering when these intersect this. And I think we said, or at least I said, that this tweaked one was a little better. So I'm going to go with tweaked graph and 3 and my graph. Okay, now listen to this word, next. These are the ones that come within our day. I want the next one. I want the one that's over here off the screen. So I've got to change my viewing window. I've got to go past 24 hours. I don't know, let's add 12 hours to that, 37. Let's add half a day. Because anything before that point is not next. Next is this one. Okay. So I can calculate intersect, and I'm looking for this point of intersection. Enter, enter, enter. And we get 20, 26.776. 26.776. Okay, so 24 is midnight on the 15th. And we know that because 0 was midnight on the 14th. 24 hours will get us to midnight the next day. Well, this is 2.6776 hours after midnight. Okay, so plus 2 is going to be 2 a.m. But what about plus 0.776 hours? Well, how many minutes will that be? Well, if I take that and multiply 0.776 times 60, I get 46.56 minutes. So I'm going to say 2.46 minutes. Now, I guess you could always take that 0.56 and multiply it by 60. And that's going to be 33 seconds. So 33 seconds is more than halfway. So, you know, I would get this number as my answer to this question, and then say plus or minus 2 seconds. So those people at 244 and those people at 248, they would be fine too. So we're going to have some leeway built into our assessment answers when you're using your predictive model. Nice. Okay, if you're given an output, you want to graph that output with your model and find the point of intersection. If you're given an input, like I want to know about 10 a.m. on the 21st of March, then you want to go over to the table and put in the required value. Wow, there was a lot of stuff there, huh? Yep, there's definitely a lot to be thinking about here. And that's why we only did one problem. No, really, I just planned for one. problem. Don't forget these things exist as a typed thing in Teams, and maybe you can do that. Let's see what happens next in the next video where we look at scatter plots part 2. All right, take care.